Thank you very much. All right, so thank you for, we will not name names, but people said, oh, can we, mask please, can we not just have a fun lesson? I would love to do that, but actually we're under the pump for what you need to get covered. And I could say, oh, you know what, don't worry about it. We don't have to do this section, but then you're going to be screwed next year when you're doing methods and for some of the topics that we do, even general. So as much as I would like to say, and it would be lovely for me as well, oh, just kick back, put the feet up and have a crazy lesson. I would love that, but we're here for a purpose. I'll remind you, it's advanced maths. We have one single lesson this week, and yet we need to make sure that we can finish trigonometry. Good luck with that. We will carry on a little bit. Not COVID, that's all right. No, we'll carry on next term because, sadly, if you check day map, yes, you've got an assignment to do over the holidays. Yep, welcome. So, we should be happy with our three rules. We've got the area formula, we've got our sine rule, and we've got our cosine rule. And really, the big thing that you need to know is, what information do we need to use your area rule? Right, it's two sides and the angle in the middle for our area. Of course, you can work backwards, give the area, have an angle, one length, but again, it's got to be the two lengths wrapping around the angle. Are we happy with that? For the sine rule, though, what are we talking about there? Two sides? Yep. Opposite pairs. So we need a known pair, right? So sine rule, it's all about the pairs. Cosine rule? It's not the pairs, it's two lengths surrounded by the angle again. So the area and the cosine rule, that's what you got to think. Ross from Friends, all right? Two lengths, angle in the middle. You need to make sure that when you are finding the angle with using sine, you need to always check for the ambiguous case. Remind me, Tom, what do we mean by the ambiguous case? More than one solution. Oh, that highlighted the whole thing. Oops. How do you do that again? You just subtract 180 degrees from, you subtract your answer from 180 degrees, and then you check if that angle has got it. We'll go through that in a moment, all right? And I forgot to say that in here, you've got the added bonus of if you wanted to find the angle and you have the three lengths. Keeping in mind that is not given to you on any formula sheet. All right, so if I had cos A, that would actually end up being B squared plus C squared minus A squared all over 2BC. Can't say I'm a fan of having it already rearranged. I like to do it as I go. This should already be written in your help page, in your page of notes. It should always be there, and you can go back and refer to it if you need to. Okay? What I want to do today is look at a problem-solving question which talks about bearings. It will go over using the sine rule, using the cosine rule. So we get practice on that, and we get practice with a problem-solving bit. Once we've done that, we'll probably do two questions. You've got the opportunity to ask any questions that you still have issues with the other problem-solving. Is that okay with everybody? All right, so you need a heading, a bearings question, and you might be going, how do you spell bearings? I will tell you. So hopefully you can read this question. This is from your textbook, and it's on page, oh, thank you, 338 if you really wanted to have a look, but we're going to do it nicely. It's just so you don't have to rewrite all of this information. It's in your book. The the first thing that you want to sort of look at is you go, oh my God, a ship sails 58 kilometers on a bearing of 72 degrees and turns and sounds. What is this degrees? What's going on here? Anyone been orienteering at all? You want to tell us about bearings? Oh, excellent. All right. So, outdooretters. Basically, we have a thing that I like to call, it's true north. What? All right, so we've basically got true north. And what we're saying true north is we call that 0 degrees right at the top. And if you really want to be fancy, some people put a 2 there because we just call that degrees true. True north. Have you heard that before? T. True north. If you go true north, you're just heading north. That's all it means. All right? So nothing to be alarmed about. And basically, if you go clockwise, if I'm moving around here, go all the way, our good old friend, east, how many degrees is east? Yeah, 90 degrees. And then our good old friend south is 180 degrees. And we've got west is 270 degrees. I bring up one of my students from a few years ago. Can you stop that? I'll name names. Hans. And he said, because I went, oh yeah, never eat soggy Weet-Bix. That's how you remember, never eat soggy. And he goes, oh yeah, my teacher told me, news. And I'm like, that wouldn't work, news. Because but anyway, he goes, no, you go news. I said, oh, okay. If you want to remember it like that, go for it. But anyway, I do never eat soggy Weet-Bix. So this is where I get to tell you where to go. Right? Where to go. So if I told Oscar, I'm about to tell you, Oscar, where to go. I'm telling you to go 100 degrees. Where would that be telling you to go if I said 100 degrees true north? 100 degrees true, whereabouts would I be going? Just below east, right? So we go, whoop, that's 100 degrees. Does that make sense? Yeah? Arena, I told you. I'm telling you where to go. I'm telling you go 300 degrees. Where's that going to be? Where's 300? 90, 180, 270. Ooh, what's back up here, by the way? 360 degrees all the way around. So, I don't know, 300 maybe there? I don't know. Do we have to be exact? No. But you have to be reasonable. Yeah? Right. Can you go and put that in the bin outside, please? Oops. So, we, using that knowledge, are going to draw our own diagram. Everyone happy? Okay. This is where we do our diagram. And please listen, and you are going to do this with me. So pick up your pencil, or actually wait for one moment. To start a diagram, we do this. Very difficult. We put a dot. And we pop our line there, which represents our north, our true north. And we're now going to go, all right, sails for 58 kilometres at a bearing of 72 degrees. So again, here would be 90. So where do you reckon 72 would be? About there? Okay, so I'm looking, by the way, and the other one's 41. All right, so I'm going to go, I've got a bit of space here, so I'm going to go. You could use a ruler. You could use a steady hand if you so desire. And we make sure that we pop in here our angle. So we're going to put 72 and I'm going to pop 58. So far, easy, correct? I would also recommend that you do get a second colour. If you're using pencil or pen, get 2 colours. Once you've done that, you have to put your north again, Because if we're looking here, a ship sails, he's sailing off here at 72 degrees. Once it's past the reef, it's going to draw a reef, but I can't draw the reef, right? It turns and it sails for 41 kilometres on a bearing of 158. So it stopped over here, does a bit of a look around, and now it's going to head from true north, not from this angle, but from true north, 158 degrees. So where is 158? That's 190. 180 is down here, so where would you like me to go 158? In the middle? Okay. Roughly, right? It's just, doesn't have to be too rough. Now, if I did that, would that be okay? No. Why not? Right, because it's smaller. So it doesn't have to be to scale, but it should be reasonable. Does that make sense? So shorten that. Okay, and once again, pop your information in. That's 41. That is 158. And your job is to find how far is it from the starting point. So we want to find this. And I might even say, can you also find the bearing? So how far is the ship from its starting point and the bearing from the starting point? I would say 9 out of 10. In fact, 99% of these questions, they're all going to be the same. We do this, we want to find x, and the first rule that you're going to have to use is your cosine rule. And then you'll use your sine rule to get your bearings, right? We go, okay, yeah, I can live with that. Use your cosine rule. 2 lengths. Oh dear. You do not have the angle in the middle. You must have that angle in the middle to use your cosine rule. Now, I'm telling you, honestly, you should be able to find that angle without using trigonometry at all. Can anybody work out how we can find the angle without using trig at all? Pardon? Circle? Yes, circle has got to do with it. How many degrees in a circle? 360. There's one other bit of information that you need. Yes, Sarah? A triangle with the 72. What do you mean? Here? No, because you don't know how far that's going up. That's just going over and over and over. It's just your direction. You want to join this? But then you still don't know. Now, I'm going to add one thing because I think Tom knows as well. What do we know about these? They're both heading north. So they are parallel. And right behind is over there, we've got some of our rules for parallel lines. But what do we know about the angles in between the parallel lines? What do they have to add up to be? 180. That's right. So if this was 72, what would that angle have to be? 180 take 72, 108. Yeah? So this angle here, we know has to be 108. Now with JPB's information of all the way around is 360. Yeah, I'm going to go to get theta. This is going to be 360 take 108 take 158. Pardon? 94. Do we like that? And it will be pretty much the same every time, depending on your diagram. So we might not head off in this direction. It might be that you head off in that direction. Your diagram will tell you every time. That's why it's really important to draw your diagram. Can you now go ahead and find x? Because if you remove all the white noise, what you should have and what you can see is we've got a triangle. That's 58. That's 41. This is 94. Please find x. What are our two lengths? So we're going to go 58 squared plus 41 squared. Again, Mia, if you had put 41 squared plus 58 squared, same deal, minus 2 times 58 times 41 times cos, and it has to be the angle that's opposite your length, so it has to be your 94. Okay with that? Noah, you okay with that? All right, a little bit of nodding, that'd be fine. It's now a calculator job. Pop it in your calculator. I've got my old one up here. I was doing with my year 8s. 58 squared plus 41 squared. Right? We get this. This is what a lot of students will do. They write that down and I mark them wrong because, as Tom has said, this equals x squared. Don't forget to square root. And I'm not writing anything down. I'm going to go straight to x equals. So, I'm going to square root my answer. 73.33. Excuse me. You are going to check. Does that seem reasonable? Look at your diagram. Is it reasonable that you're going 58, 41? Yes. Seems on the money. Okay? Added to this question. I'll just wait a minute. Okay, this bit is not in your example. I've added this because when I do a question, I will definitely ask you to do this as well. We want to send the search party out to get this boat. So we need to find this whole angle. Any ideas how we're going to do that? We will be using the sine rule, but yeah, excellent. So you're actually going to find this angle first, right? So fish. So year 10s, can I just ask, one, could you do the courtesy of actually listening? Questions that people have are great, and if you have a question, can you put your hand up? All right, so remember we talked about with angles, instead of calling an angle x, we call it theta. The Greeks did a whole lot of work with trigonometry and writing it down. So some of the symbols that we can use, we could use theta, we could use, that is alpha. We've got beta, we've got phi. I think this one is gamma. There's a whole lot. There's epsilon, whatever. I'm hoping I never have to get to that many to use. I'm normally happy with these 4. Okay. There was one. Actually, here you go. That's gamma. I don't know what that one is. That could be epsilon. Anyway, that's the methods. Okay. So, we want to now find this angle here. Who thinks they know how to do it? Right, no one's putting their hand up. So, excellent. If you don't know what to do, what would be something that would help you? Well, I would be saying, I look at that diagram and I go, oh my God, busy, 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 busy. So if you come back to this, right, come back to this diagram, we now have what x is, don't we? That's 73.33, and I'm trying to find this angle. Could you now solve that angle? How, Slavi? Yes, because we've got a known pair, and then we've got that one. Yeah? So again, it's not just about getting the answer, it's about what can you do if it looks confusing. Simplify it out. Get rid of all the white noise there, and then that will help you. So here we go. We're going to go sine alpha over 41 equals, Ash, take it away, equals what? What's it going to equal? Sine alpha over 41 equals, what's the other pair that we have there? Sine 94. Yeah, over its opposite length. Well done. 73.3. And now it's a little algebra doodad. You have to get sine alpha by itself, so we're going to get rid of the divide by 41. We will. Times. Yep. And then to sus alpha, how do I get rid of the sine? Inverse sine. Yeah, hopefully it's easy, but you know, it's easy on paper. You'll practice one in a minute, yep. And hopefully you'll realise I haven't lied to you. They're pretty much the same thing over and over again. So check for ambiguous. We go 180. Take 33.9, and again I'm saying this for when we have just normal triangle questions. You would not do this in a bearings question, right? I'm just doing it to remind you. So we're actually nearly done. So we go 180, take 33.9. What is that? That's like 146.1. Yeah? And you go back, oops, and you check your answer here. What is 146 plus 94? Is that possible? No. So, no way we cannot have an ambiguous case. Yes? All right. Last bit. Coops? We done? No. Why? You have to do that. Right, because if you say, off you go search party, go at 33.9 degrees, you're sending them off here, and they're lost at sea. And it's your fault. Okay, right, so your final bearing that the search party has to head out to is going to be 72 plus 33.9. Aiden, did you get that? Because you were talking. Yeah, you were. To Mia. So do you understand that, both of you? Excellent. Okay, we are focused, and we're not taking all day to do this because I want you to now have time to ask questions of other bits. So here we go. Same thing over and over again. How do we start? Dot in the middle. We're starting with the dot. I like to do this a little bit. 111, and then we're going to go there. Okay, so dot, 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 dot. There's my true north. Easy enough. We're heading off at 111 for 83 meters. So where is 111? And now I go, ooh, I might just shorten that a little bit. So where's 111? A bit down. That's right. So 90 is there, 111, 111, and we pop 83. Got it? Ollie, you're either doing this, in fact, get up, come and sit at the front. Let's go. Beg your pardon? Then step outside. We do our true north again. And now we want to go 214. We've got 90, we've got 180, and here is 270. So whereabouts is 214? I don't know. Doesn't really matter. About here. And, 78 and 83. I might go just a little bit longer, but not really fussed. So this one is going to be a little bit tricky with is my diagram going to be exactly spot on. So that's 214. and this is 78. This is where I think the colour comes in handy. You could feel free to disagree. Find x. This is just like the last question, where we're going to use the cosine rule first, right? But to use the cosine rule, I need my two lengths, which I have, but I need to find this angle in the middle. You're going to do that without using trig. What do we use? Parallel lines and 360 degrees in a circle. So, Taya, remind me, what do we know about the angles inside parallel lines? They add up to be 180. So if this is 111, what's this angle got to be? 69. I'm waiting for him to make a comment.
Oh, here he has.
Yeah.
No, I didn't even say anything.
Year 9. Go back to year 9. And therefore, to get theta, that's going to be 360 minus 214 minus 69. And then you should be able to find x.
77.
Yep. So go ahead, those who want to. Listen. Once again, you have to pop your dot. Oops. All right, there's my north. We're going to go 138. Ooh, so 190, 180, so 138. Yep, pop it like so. And then a further 11 kilometres in the direction of 67. Now this is slightly different because it's sort of within the triangle, if you sort of know what I mean. So we're going here. There's my true north. Slavi, what are you doing?
I'm trying to open up.
And then 67, how far are we going?
11.
11, so pretty much the same. So we're going 11, and my 67 is here. So a few people, when they've been doing this, went 67 was the whole angle. Niet. Right? And we want to find that. But our issue is we need this little bit here. Exactly what we were doing before. It's all about our parallel north. If you don't draw your north lines in, you won't see your parallel lines. So if this is 138, oh sorry, I read yours wrong. I think you said 135. So 138, that means this angle here is 180. Take 138, right? 42. So now we've got our whole angle, but it's all about a neat, well-labelled diagram is going to get you there. Yeah? Because you said, I'm reading yours, 135.